Okay, so let's look at static lifetimes. We've already looked at lifetimes briefly, and static lifetimes hopefully will be even simpler to understand. So with references, you use lifetimes. Static lifetimes you can use with the string literal, which doesn't actually get stored on the stack or the heap. It actually gets stored within the compiled code. So first, let's consider a dangling pointer. That occurs when a reference points to memory that's already been deallocated, and then the reference outlives the data it's pointing to, and then you get a risk of invalid or freed memory. So what we have here is, let's look at the function first. So the function is returning some text, we'll call it for now. So it's going to be borrowed or a reference to a string. So hello, and then we want to return it. So we're going to return the reference to it. But the problem is when we call it, the reference has already gone out of scope. So you'll see here, missing lifetime specifier. So it's trying to help, but in actual fact, even that doesn't solve the problem. It takes you part of the way there. And we'll get to that in a second. So returns a reference to data owned by the current function. Once the current function's gone out of scope and you've gone back to the main code, then it's obviously no longer available. So this is a solution that it would come up with if you are going to use the static lifetime on the string. So this is a string literal, so it doesn't get stored on the stack or the heap, it actually gets stored within the compiled code. That then gets returned. So when you call the function up here called improve, you're actually getting some text, which is a string literal. And you use the static lifetime to just say this is always available, because it's available for the lifetime of the program. So that is what we've got here. So if I just run that, yeah, it compiles. So you've got hyphen main and then you've got hello. So first line, that's within main, and then the second, improve. So you're setting second text to equal whatever comes back from improve, and then improve is returning a static lifetime string literal. Okay, so if we carry on, the other solution would just be to return a string. So if we did that, let's just copy that and get rid of this up here, 12dd, gone. If we save that and run it, yeah, we get the unused variable. Let's just neaten that up then, shall we? So this is a bit quick and dirty, but we'll do it anyway. So there we go, just allow unused. And there you go, hello. So that is actually sending back hello, which is a value. So it's not passing back by a reference, it's passing the actual value back as a string. And then you set your second text to that string, which is hello, and then you print it. So that's probably more easy to follow because it is just passing back the value. But when you're working with references, yeah, if you want to pass back a reference, then you want to just say string literal here, or make it a string literal and do ampersand tick static. So in the other video, we looked at ampersand tick A because we were using several references there, and we were using, forget what we were using. We were using a function where you were passing in one or more references and you were obviously returning a reference and they had the same lifetime. So yeah, I'll make this available. I'll try and I think I can make this into a link, so I'll put this link into the video description, and that's it for now. But just a quick look at static lifetimes, and hopefully static lifetimes will kind of join the dots with the lifetimes for the references that we looked at in the other video. So this video hopefully complements the other one. Thanks for watching. We'll be back soon.